Welcome back to your AP Calculus videos. This is part 5? 4? 5?
It's 4.
It's something. We did 1 through 10, 11 through 20, 21 through 30, that's 3. And then we did 75 through 83. And now, part 5.
Did you ever find out if our corporal work study is like, excused?
Oh, that I'm supposed to find out?
Well, yeah. You said you were.
Do I go to work with corporate work study?
Wait, so do we take the test or do we go to work?
You take the test.
We go to work, but they're saying that you go to
So do we
work.
have to make it up?
Who's saying you go to work?
From a work
Have you emailed them say I'm taking the AP Calculus test on that day? It is on the calendar.
So then they should know.
Do they read the calendar?
No, they should.
There's so many assumptions going on right now with people like checking email. You already mentioned like who checks email,
Yeah.
right? Yes, it is on the calendar.
I skipped 10 minutes.
Calendar. Wait for it. Not this week. There it is. Senior last day of classes. I put this here, but they put that there. So that's the admin. The green one is the admin, so it's on there. But you're assuming that they check the academic calendar.
Yes.
So send an email on behalf of everyone.
No.
No, not you. Okay. You can tell who.
I think they're saying that.
Yeah, let them know.
Yeah. Senior class president, right there.
Senior class president, Amy. My goodness, I think we've landed on Amy. Okay, let's do 84.
No, BCC.
There you go. BCC, everyone. I like it. All right, 84. Okay, we've got a function. It's continuous. Okay, they've given us a table of values. Which of the statements must be true? What do you guys think about A? Has at most 1 0. Doesn't sound like we like A. Sound good? Okay. What about B? The only time I've looked at relative maximums is when I first take the derivative and find out what makes that equal to 0 and go from there. Do I have enough information in this question to find the derivative? No, so it's not going to be B. Okay. Now, letter C is talking about the intermediate value theorem. And letter D is talking about the mean value theorem. I know you guys all read the Calculus for Dummy books or pages. All right, so you guys remember what these mean. All right. So we're going to see which one is going to be true here. So just as a kind of aside, if you're going to use the mean value theorem for a function, then your function needs to be continuous and differentiable. Does it say anything in this problem about the function being differentiable? No, it's just a continuous. So I'm not going to be able to use the mean value theorem. So let's talk about the intermediate value theorem, which all has to be is continuous. This states that if f of -5 and f of 2 are on opposite sides of f of our c, then we will have a value c that would be true to be equal to 4. All right, so let's see. Use the table. What's f of -5? Excellent. Okay. What is f of 2? 5. And they're asking us, is there a number c that when I plug it in, I get 4? What do you notice about 4? It's between -9 and +5. The answer is C. All right, so that question came down to, do you remember the intermediate value theorem? All right. Thank you for your honesty. I did have something that's never happened in my career of teaching. A student asked, how am I going to take notes? I said, what do you mean? Because she had her nails done for prom, and she couldn't hold a pencil to write in the notes. The first time in history of teaching, someone has asked, how am I going to take notes? Because my nails are getting in the way.
How long were they?
Long enough that it caused a problem. So I said, you're taking an AP exam in 1 week. Can we make sure the nails are gone by then? Right. So, note. Yes. What have you been doing? Got a sharpener up there in front. You're welcome.
How's she gonna take notes?
Right? Not a pencil. But that one happens all the time. I'm always surprised that students do that. All right, let's do 85. All right, we're going to use some technology here. It says that f is an antiderivative of the function g. All right, so if you want to think of this as another way, is that g is the same as f prime of x. All right, you can think of it like that if you want. All right, it says, which of the following is the x-coordinate of the location of a local maximum for the graph of y equals f of x? Now, this is going back to, we talked about this in other questions, that if you look at the first derivative, all right, where it's positive, that means f of x, or the original, is increasing. If you look at the first derivative, where that's negative, then f of x is decreasing. All right, so let me graph this. So turn your calculator on. Let's graph the derivative of our function f. So we're going to graph g. You guys ready? All right, let's turn it on. If you want to clear out all the stuff, I'll show you how to clear all the stuff because other students are using them. You know, Merle, imitation is the sincerest form of flattery. I told a 6-year-old on our T-ball team because he kept copying what I was saying. I was like, okay, Jace, you're up. He's like, Jace, you're up. It's like, Jace, go to right field. Jace, go to right field. I was like, okay. I love coach. All right. Let's type it in. Oh, let me try to delete it all. So second memory. You go to reset, second memory. Reset, which is 7. And then all RAM. Yes, reset, number 2. It's just above enter. The plus sign. Second plus sign. I'll do it again. Second mem. Number 7 is reset. Do you guys have number 7 reset? Okay, and then all RAM, number 1. Yep, reset it? Yes. Number 2, reset. Boom. If you do that, I mean, you're going to do that before you take the AP exam anyway because you have to. All right, so you have nothing in there. All right, so I always did that when I was using community calculators because I didn't want to like other stuff in there. All RAM, hit 7, hit enter on 7. All RAM, and number 2. Yes, you did it. Okay, hit y equals. It's the top left. Y equals. Let's type in what they gave us. They gave us 3 minus the square root of, thank you very much, Merle, x squared plus x plus 4 cosine of x. Thank you. This right here, Merle?
Yeah.
All right. What happened, Fernanda?
I can put it in the
That's okay.
then I have to restore.
Oh, sad. You can just hit delete.
Oh, yeah.
DEL, delete. Right, just think like this. These calculators came out before you were born. They came out before you came out. Right? You ready? You good? No shit.
Okay.
When you're ready, hit graph, top right. Top right where it says graph. I know.
It's
Don't-
like in slow motion.
Yes, exactly. That's what we're working with. This old technology.
Okay.
Got it, Amy?
Yeah.
Graph. If it doesn't look like this, right, you can always hit zoom. Do you see the one that says zoom? Top middle. Zoom, the one that I use the most is Zoom Standard. You see number 6? Zoom Standard. You hit Zoom Standard, that gives you your negative 10 to 10 on both X and Y. Did you hit graph? Top right. Graph. Yeah? Does it look like that? Okay, so remember what we just wrote down. We just wrote down, remember, this is the derivative. Okay, this is the derivative. And we're trying to figure out where there is a local maximum. A local maximum. So if you think about a maximum, right? I'm thinking about sketching a maximum. That means I'm increasing and then decreasing, right? So increasing to decreasing would be a maximum. All right, so I need to look at where is my first derivative graph going from positive to a negative. From a positive to a negative. So let's look at the graph together. Where is it going from a positive to a negative? Here's a negative to a positive, still positive. So a positive to a negative. So right there, whatever that value is. Okay? Now you probably approximate it and get the right answer. Let me show you how to find it exactly. All right, do you see where it says trace? Don't click trace. Hit second trace. You want to calculate. Second trace. We good over there? Any? No. Do you need a substitute calculator? Yeah. Bring in the reliever. That's okay. Don't throw it on the ground. All right. Second trace. Second trace, which is calculate. All right. We want to calculate where it's crossing the x-axis. What's another name for that? Interesting. That's not what I'm going to be doing. Intersect for this calculator, you're right. Intersect for this silly technology is where you have two curves where they intersect. Okay. Somebody said it, okay? 0. So number 2. Hit number 2 and then enter. Number 2. Okay. So now it's asking you essentially, hey, where do you want me to look? Okay. I know it's weird to think the calculator is talking to you, but it is. So left bound, I'm trying to go to that point. You guys see it? It's kind of around 3. So go over on your arrow to the left of 3. Mine says 2.27. It doesn't mean exactly mine. Just close to it, but to the left. Hit enter. Right bound. Go past it, guys. Go past it. See how I went past it? No, Joel? Did I do it too fast? I'm sorry. Left bound is to the left of 3. So I'm trying to find this 0, right? So if I go to the left bound, something to the left of it. Hit enter. Then it says, hey, right bound. It's basically asking you, where should I look? Where's the window that I should look for this? All right, so I want to do it over here, and it's going to give me, wait for it. There we go. See, I'm telling it, look in that window. You see that now? Like, look in that little spot. And then it says guess. You don't need to guess. If you want to guess, you can scroll back over, but you don't need to guess. It's going to do it exactly for you. All right, do you see the 0? It's 3.14. So at 3.14, hey, right? Everyone's favorite pi, right? At 3.14 is where we have a local maximum. So the answer is D. What's up, Jennifer? You can get it? Don't worry, because you're going to watch the video later, right, when I post it. So far, because I checked my email, I have not received an email. Good job. I have not received an email that said somebody has watched my other part videos. No, I haven't received an email. No one's watching. I see. Okay.
And we're here.
Yes, you
They
are.
come back, they're going to watch it.
Yeah.
They're totally not going to watch it. That's okay. Let's do 86. Okay. I told my juniors that I teach that I'm going to teach Calculus 2 next year, that for Calculus and Stats, we're going to do a flipped classroom. So they got to watch the videos on their own. Good for him.
Why didn't you do that first?
Good question. We didn't think of it, and also we didn't really have the capacity for it because all the math teachers are teaching max capacity. It is. But it's the best. Ready? We can do this one. All right. We don't need any technology for this one. We can do this. We can do this. We've done this. We've done a ton of these. Okay. Here's the original function, f. It wants to say, okay, here you go. Here are possible derivatives. Do you remember how to do this when you're looking at the original? What are you thinking for? What is the derivative of it? What's another way to describe the derivative? It is a rate of change. What's the very first rate of change you learned in math?
I was going to say that I was drinking my Monster.
Oh man, sometimes, you gotta unleash the monster. What's the very first rate of change you learned in math? Probably in middle school. What is it? Say it.
I don't know. Slope.
It's slope is right. Rise over run. Slope. See? You know why you got that right? I think you said slope, right? Yeah. It's because she drank the monster. Okay. So slope. So as you look at the beginning, right, how would you describe the slope from here until 2? It's increasing, a positive slope, right? Actually, it's not increasing. I want to say it's positive, right? It's not actually increasing. It's not changing. So if you look, all of them are constant, right? Do you see that? Because it's not changing. It's the same slope. But do you see how it's a positive slope? And look at letter C. That's a negative number there. So no, not letter C. Let's see. I think Amy, you mentioned this. Maybe it wasn't Amy. It was someone else. Do you remember what happens when you have this sharp corner here? Not nice. It's not differentiable. So notice on all the answer choices, what's happening at that value of 2? There's some kind of discontinuity, right? Some kind of discontinuity. Some of the whole, some have jump discontinuity, right? So the idea is that that's happening on all of them. So I can't really use that to help me out. But the moment we get past that, what do you notice about this slope? It's negative. So look, is my slope negative right after 2? Yes, that's negative. Those are negative values, just negative y values. Is that a negative y value? No, that's not a negative y value. What about letter D? Is that negative right after 2? Yes, it is, Raquel, the negative y values. Just negative. You're focused on like increasing, decreasing. I just want the y values. They're negative, okay? Now watch this. When does it start becoming a positive slope? After 3, right? Right here, now my slopes are getting positive, all right? And you notice, if you look at our 2 options now, at 3, this should be what? These should be what numbers? They should be positive numbers. Are these numbers positive down here? No. It's A. So like if I were to draw, I think I always use orange because I like orange. But like right here, it's positive slopes, right, for the derivative. So the moment I get past 3, I should have positive y values on these graphs. I got past 3, and I don't have positive y values there. Those are still negative y values. But here they're positive. Are they all good?
Yeah.
All right. How's Eder doing?
He's good.
Excellent. Tell him I say hi.
Okay.
All right. Tell him not to stress.
You know you didn't want to go to Paris because of your AP.
I know. That makes me sad. Happy, but also sad, right? No stress. Eder needs life stress-free for Eder. Okay, 87. 87. I don't want him dead at 30. All right? 87. That's how old he's going to live. 87. Gosh, can you imagine Eder at 87? I'll be long gone. Okay. Let's do 87. This one is giving us the velocity of a particle moving along the x-axis given by this function. All right, it says t equals some time b. I don't know what b is yet. We're going to find it. All right, at which the particle changes direction from moving left to moving right. So watch this. Let's graph it. Let's graph this velocity. So go back to your calculator. We're going to type in that velocity function just as a word of wisdom here. When you're doing like v of t, just think of it as v of x. We're just going to use x's. All right, same thing. No worries. All right, so go back to the calculator. Y equals. All right, clear it out. Hit clear. All right, let's type in the new one, which is x times the sine. X times the sine. Is it x cubed? X cubed. If there's something I'm pushing and you don't know what I'm pushing, you can always look at like a running button so that I'm pushing at the bottom, or you can just ask. There's only 12 of you. So. Everybody okay? Amy, did you get it in? Man, I would not have to work anymore if I got paid 5 cents for every time a kid did that to a calculator. I'm like, peace out. Okay, let's hit graph. Whoa. There it is. Did you guys get that? Okay. Now it's hard to see here. So you'll notice on the problem, it says 0 to 2. Do you guys see where it says time t 0 to 2? So what I'm going to do is I'm going to click window. Do you guys see window, the top left? If you click window, I want to focus on 0 to 2. So I'm not going to use 0 and 2. I'm going to use for x, I'm going to use the min is -1. Make sure when you're clicking -1, you do the button that's next to enter. So that's -1. And then my max, I'm going to use 3. So just go past it a little bit. And then hit graph again.
There's no control V on this.
No, there's no control V. I'm telling you, we're talking about like dark ages here. Right? Like when you guys were you guys took world history sophomore year? Right? Did you go through the unit where humans started using these? Like mid-10th century? Yeah. Okay. Now, it's hard to see. All right? Try my best here. It's hard to see. But we're starting out at 0, 0, slowly increasing. All right? Then we go negative here. All right? And then we're back to positive, and that's 2. Do you guys see that's 2? All right, so that's 1 and that's 2. All right, so let's think about what's happening to the particle. Okay? So moving to the right. Yes? Moving to the left. And then back to positive. This last one is moving back to the right. So the question says, at which the particle changes direction from moving left to moving right, we need to actually look at the second 0 right there. All right, so not the first one. This first one would be moving right to left, but it says moving left to right. So negative to positive. You see a lot of blank faces. Let me try again. Okay. So if it said moving from left to right, that'd be positive to negative. So this 0. But it said in the problem, moving left to right. So I'm going to go back to where it goes negative to positive. So the second 0. So do you remember how we found the 0 before? What did Edgar say?
He said hi.
Okay.
Wait, I didn't say not to stress.
I said don't stress. Take a nap. Okay. Second trace, which is calculate. Second trace, which is calculate. What are we trying to find? We're trying to find 2, yes, a 0. So number 2, hit enter. All right. Now remember, I want to go to the second one. So when it says the left bound, watch how far I go for the left bound here. All right, so I'm going to go there, about 1.8. Are we okay with that? Okay. Enter. Right bound, I'm going to go past it. Let's go past it. 1.9. So I'm telling the computer, look there and find the 0. Okay, so what is the 0? 1.845. 1.845. Say it one more time. The middle number? When it says guess? Just I just hit enter after the guess. As long as I tell them the left and right, it should take me there. Did it? Okay. All right, now, what we're going to do to find the total distance traveled, all right, the total distance traveled, and this is a long time ago, all right, we're going to find the integral from 0, so time is 0, to 1.845. That's the time that the particle changes direction from moving left to moving right, All right, and remember, we're going backwards from the velocity function. Remember our PVA? What's backing up from velocity? Position. So we're trying to find the position function, essentially. But we're going to use technology to have it calculate for us. And here's where you might make a mistake. All right, if you're this far, very impressive. But we want the total distance. And if you notice, right, when I graph this, we had some that's above 0 and some that's below 0. All right, so if I just right now were to type in the integral of t times the sine of t cubed dt, I would not get the right answer, right? Because I'm going to have some positive and some negative. And what happens when you add opposites together? They cancel out, all right? So that's called displacement, all right? But we want the total distance. So do you remember what we did? We did this a long time ago. What symbol we put around this to make sure that we get the total distance? Nice, the absolute value. All right, so we're going to type this into the calculator. All right, so now I'm going to clear out of this. All right, so I don't need the graph anymore, so I'm going to hit clear until I get back to the screen. So hit clear a couple times. There you go. Hit math, right? You're in math class. I want to do an integral. Do you guys see number 9? Number 9 is the integral. So number 9, I'm going from 0 to 1.845? And then here's how you find the absolute value. Make sure you get into the parentheses there. You're going to hit math again. And then you see where it says NUM for numer. I guess that's probably number, but it could be numerical operations. I'm not sure what it is. But hit NUM for num. Wait for it. There it is. And you guys see number 1, right? This is not working on your core, right? Abs. That's for absolute value. All right, so number 1 for absolute value. That will put an absolute value symbol in there. Now we're going to type in the x times the sine of x cubed. Don't forget to put the dx at the end. Ah, too far. There we go. Math num. When you're ready, hit enter, and you'll get your answer. .011, which is C. Look at that. Amazing. 3 more to go. Okay, let's go to 88. All right, it says, for how many values of x on this function in the open interval between 0 and 1.565 is the instantaneous rate of change of f? That's a fancy way of saying one simple word that you need to know in this class. It's like we say it the most. Starts with a D, derivative. Very good. Instantaneous rate of change is just derivative. All right, so really, really fancy way to say it. And the average rate of change, all right, where are they equal to each other? So let's first find the average rate of change. I think we can find that a little bit simpler. So I'm going to find the average rate of change, which is going to be f of 1.565 minus f of 0 over 1.565 minus 0. All right, this is going to be the average rate of change. All right, now we have the calculator for this question. So I'm going to just take this and type it in, and where it says x, I'm going to put 1.565. Okay, so I have 1/4, so 0.25 times 1.565 to the 4th power minus, there we go, minus 2/3 times 1.565 to the, is it third power? Excellent. Plus 1/2, which is 0.5, times 1.565 to the second power. And then finally, minus 0.5 times x. Do you guys want to go to the beginning? All right, let me know when you want me to go further. I'm going to be a student right now. Mister, can I charge my Chromebook?
No.
Marley says no. Gosh, Marley savage. It's that monster. Oh man. Marley.
No.
Monster. Starts with that.
No.
Should I go over? Everybody okay? When you're ready, hit enter.
Mr. Brandon starts with M2.
Nice. Well done. Yes, that's right. But I'm not drinking a monster.
That's what you've been thinking.
All right, hit enter. This is not the average. That's not what you got? Oh, now I'm worried if I got something on tape. Did somebody?
No, I got the same thing. I thought I got it wrong, but I got the same thing.
Okay, good.
When I did something wrong.
Sad. Okay, so that's not the average rate of change. That's the numerator, right? And if I were to subtract, don't look at me like that, Joel. If I were to subtract f of 0, this is really nice, Joel. If I plug in 0, what happens when I plug in 0? You get 0, right? 0 to the 4th power. That's all 0, right? So that's nice. What's the denominator become? Just 1.565, right? So let's just divide that. Hit divide, and it'll tell you, oh, we're into the answer. Divided by 1.565. All right, so I want you to write this one down on your paper. Negative 0.392. Okay? Now, that is the average rate of change. Okay? We need to figure out, right, how many values in this interval is the derivative going to also be equal to that. All right, so you probably noticed as you read this, or maybe you didn't, that's okay. But if you were to take the derivative of your function, do you see how they've kind of set it up nicely for you? Because what's 4 times 1/4? It's just 1. So it's going to be x cubed minus, anyone? 2x squared, nice. Plus x, nice. And then minus 1/2. So what I'm going to do, guys, is I'm going to graph this, and I'm going to graph this. And when I graph those two, I'm going to see how many times they intersect each other between 0 and 1.565. And that will tell me how many points that the values are equal to each other. All right, so you ready? Let's go to the calculator. Go to y equals, clear this out. I believe it was, I already forgot, was it x cubed minus 2x squared? This is the derivative. And then plus x minus 1/2. What was our value that we found for the average rate of change? Negative 0.329? Thank you, 392. Appreciate it. What happened?
I'm trying to press down. I was cute.
Oh my gosh. I know. Every time I use these, this calculator, I'm like, Desmos, I miss you. Why are you not charging? Thank you. Gosh, what is happening? All right, hit enter. I'm sorry, hit graph. Now, let me see if I can make that a little nicer for you. Let me hit window, and I'm not going to do -10 to 10 for my y min and max. Let's do -5 to 5 so I can see a little bit more space between. The space between. Looks like it's happening between 0 and -1, right? So let's get even closer. There we go. Okay. Wait for my red line. Yes. Okay, how many times is the red line intersecting with the blue curve? 3 times. You guys see it? So the answer is C. Yes, Jennifer, another one? No. Oh my gosh, guys, we're so close. 2 more to go. Oh my gosh. I'll be honest with you. I was on here yesterday, and while one of my children was napping, I was working on the free response questions, trying to do that. Wow, are they challenging?
That's why I did a good job.
So I can't wait to go with those. Ooh, those are tough. I finished the problem. My wife was at her desk working for nursing school. And I finished the problem. I got it right. And I was like, A, it's sad that I'm so excited I got this right. And B, this is the second instance of Beth.
It's not that. I just didn't say it. Tell him if I can borrow an experience. I'll G-chat him.
Can you G-chat him?
No.
Okay. Not allowed to. And B, why would I ever need to know how to do this in my life? That was the second one. 1, so excited I got it right. So excited. And number 2. All right, here we go. 89. Let's do it. We're almost there. Gosh, we're so close. It does, yes.
Disappointed.
Douglas. That's my name.
Yeah, I'm not gonna say it.
When you graduate, though,
Yeah.
you can walk by and be like, "What's up, Doug?" There you go. You'd be surprised at how many students are like so excited to do that.
I'm excited.
I'll be like, "Okay, Marley, graduate college now." All right, 89. Oh my gosh, twice differentiable. They tell us that oh my God, here we go, guys, we can do this. We can do this. We don't need technology. We can do this. I'm going to stay here because I'm charging. I know. I'm sorry.
No charging can make that.
Sad. $10 a percentage point. Okay. It says the derivative, the first derivative, here we go. First derivative is greater than 0. What does that tell us about the original function? G of x must be what? G of x must be what? First derivative is positive. Hey, what is it? No, well, it says the first derivative is positive. So what does that tell us about the original function? It's increasing. Yes. What did you say, Jennifer? I totally understand, Marley. Thank you. And that's why you did all those drawings. All right. The second derivative is positive. Who remembers this one? Sad. There we go. Concave up. Here we go. And don't worry, for those of you that are thinking, man, what does that mean? I will explain that. Okay? Yep, up cup. It means that the rate of the increase is actually going up, which is weird to say. The rate of increasing is increasing. It's weird. Okay, now, I like to do for these problems, and we did a couple of these when we took the test on this unit. I like to plot, and guys, it's just a sketch. You don't need something to be beautiful here. It says G of 3 is 12, so here's 3, 12. All right, everybody good there? Yeah, that's 312. And then here is 518. Yes, everybody good? Now it's increasing and it's concave up. So watch how I'm doing this. Increasing and concave up, right? Everyone see what's happening? All right, now here's what I do. My brain knows that if I find the line that connects these 2 points, all right, and really the slope, I'll do the whole thing with the line, but really if I can find the slope of the line that connects those 2 points, that will give me kind of the lowest value when I compare to what they want me to use for 6, right? Because ultimately, if the rate of the increasing is going up, right, we're increasing in concave up, that means my slope has to be going up as well. So here's what I mean. All right, let's find the slope. All right, so that's going to be 18 minus 12 over 5 minus 3. All right, so what's the slope of this line? What is it? What's the slope of this line?
3.
It's 3? Yes, it is. Nice. 6 divided by 2 is 3. I love it. Okay, so now I need a point, and I'm just going to use my first point, which is 3 to 12. Do you guys remember the point slope form? Excellent. Equals m times x minus x of 1. Okay, I'm going to move that 12 over. Okay, so now they're telling me what am I going to plug in for my value for x? They're saying which of 20, 21, and 22 are possible values for g of, I'm reading the question, g of 6. So I'm going to plug in 6 where it says x. So good. So what's that? 3 times 3 is 9. Plus 12. What's 9 plus 12? 9 plus 12? 9 times 12. I see what you did. 21. Okay, now let's see if your brain can do this. It can, Merlin. It can. All right? Maybe not today, but someday. I'm right there. Here's what I'm saying. Let me try this, Fernanda. Ready? So if this was a line, Fernanda, if this was a line with a constant slope, I would plot the point 6, 21 to be on that line. Wait for it. There, you see it? That's if this was a line. Is this a line? No, it's a curve that's increasing, so going up, and the concavity is up, which means that it's increasing at a rate that is increasing. All right, so that means that my point for 6, I know it's weird to say, 6 comma 21, that's too low. 21 will not work because my slope will be higher. Okay, so I need to have y values that are above 21. What are y values that are above 21? 22, 23, 24, right? Those? All right, so which of my ones can I choose if it has to be above 21? Only B. We made it, guys. Our last one. Yay. All right, the last one. Number 9. I love this all being recorded, really. Number 90. Yeah, you'll live forever. Number 90. I'm gonna live forever. Number 90. I'm gonna cross that river. You ever heard that song? You heard that song? No. I've heard that. You should, right? Not me, the actual guy who sings it. All right. We have a differentiable function f, and it's giving us a table of values. You'll notice we have the original function and the differentiable function, f prime of x. Okay? It says g is the inverse of f. We're trying to find the equation of a line that's tangent to the graph of g at the point where x equals 2. Guys, this is a very complicated way to ask a very basic calculus question. So nothing about this is simple, but the question they're asking to find the equation of a tangent line is one of the basic questions of calculus. All right, in order to do this, we need to find the slope for this line, which is found, let me do it like this. The slope of this line is found by evaluating the derivative at that x value. And then we need a point, which in this case is going to be g of 2. Right? I don't know yet what y is. All right, I think it's simpler. Not simple, but I think it's simpler to find the y value for the g of 2. All right, do you guys remember back in middle school what it means when things are inverses of each other? Do you remember what, like, the most basic way you would have learned inverses? Remember this? Like, if this is my graph, this point, this point, this point, what's the inverse? Do you remember what you do with the x and y values? You switch them. All right, so watch this. All right, this says that when x is 3, my y value is 2. Right, this is for my f of x function. You guys see that? Based on the table, when x is 3, my y is 2. So if I switch it, right, when my x is 2, what's my y value? It's 3. So there's my point. I just found my point. That's why I think that's the simpler part of the two. All right, here's how you find the slope. All right, this is actually, if you want, I can pull up the formula sheet that I gave you. Again, you won't get this on the AP exam. Sad. But here's the formula right here. Do you guys see this inverse function theorem? Wait for it. Right there. So do you see where it says f to the negative first power? That's the inverse. Our inverse is what letter? What's our inverse? It's g, right? So I'm going to use g prime of 2 is equal to 1 over, all right, the derivative of f, so f prime, all right, evaluated at our inverse of that value, so g of 2. All right, so we know all this stuff. We just found what g of 2 is. What's g of 2? It's 3, nice. Look in the table. What's f prime of 3? It's 5. Did you just say, Annie, I didn't see the table? Oops. All right, so 1/5. What did I just find? 1/5 is our slope. So now back to your days in algebra. If we have a slope and we have a point, we have enough information to write our equation in point-slope form. So y minus 3 equals 1/5 times x minus 2. That's the answer. You'll notice that all the answer choices, they've moved over the value next to y. So what do I need to move over? The minus 3 by adding. So the answer is going to be C. All right, guys, we made it.